Hey Chem students, this is Ms. Schwemmen here, and this is just a quick tutorial on how to do some mole conversions. So I'll start with a moles to grams, grams to moles problem, and then work with Avogadro's number in atoms or molecules to moles and vice versa. And then I'll show you one where you can go all the way from grams to molecules or molecules to grams. So this first one, we are asked how many grams are in 5.370 moles of magnesium bromide. So first thing, I always like to see what I'm given in the problem. So in this case, 5.370 moles. Second thing is I'm trying to see what am I asked to find, and I want to find grams. So if I know grams is involved in my problem, I automatically have to find the molar mass of magnesium bromide. Now, magnesium has a molar mass of 24.31, so I'm going to put that down, 31 grams for every 1 mole. And I only have one magnesium atom in magnesium bromide, and then I have 2 atoms of bromine, so each bromine has a molar mass of 79.90 grams for every mole. So I'm going to take 2 times that, and when I multiply and add those all up, I'll get my molar mass of magnesium bromide, which equals 184.11 grams for every 1 mole. So now that we know the molar mass, I usually abbreviate that as mm, I can set up my proportions. So it doesn't matter which proportion you put on which side or which number you put on top or bottom to start with. So I'm just going to start with what they give me in the problem, 5.370 moles of magnesium bromide. And I'm looking for X number of grams of magnesium bromide. And I always want to put units with my number. We don't want any naked numbers in chemistry. Then my second proportion, I'm going to use my molar mass that I just found. So I see that I have grams on the bottom, so I want to put my 184.11 grams of magnesium bromide on the bottom. And I have moles on the top, so I know my molar mass is for every 1 mole. So I'm going to put 1 mole on the top of magnesium bromide. And now that I have my proportions set up here, I can simply cross multiply and solve for x. So after cross multiplying, I would end up getting 5.370 moles times 184.11 grams equals 1 mole times x grams. And to solve for x, obviously you don't really need to do this, but just in case we forget our algebra, divide both sides by 1 mole so that I isolate x on the right side. And when I multiply the 5.370 and 184.11, I end up getting 988.7 grams of magnesium bromide. Oops, Br2. And that would be my final answer. Okay, so for number 2, now we're looking for a mole to molecule, molecule to mole conversion. So first of all, I realized that I made a mistake on my formula. We're going to change that to calcium hydroxide instead of sodium hydroxide. For our purposes, it's not going to matter a whole lot, but just so we're correct. So we have the question of how many moles are in 7.92 times 10 to the 24th molecules of calcium hydroxide. So we're given number of molecules, we're trying to find number of moles, And nowhere in my problem does it mention grams or mass, so I don't need to find the molar mass of my calcium hydroxide. I can just set up my proportion right away. So I'm going to start with what we're given, 7.92 times 10 to the 24th molecules of calcium hydroxide, and I know I'm looking for X number of moles. And Avogadro came up with the unit the mole, and he said that for every 1 mole, I'm putting moles on the bottom here, so it matches my moles on this side. For every 1 mole, there are 6.02 times 10 to the 23rd molecules or particles or atoms of whatever we're talking about. So now we have our proportions set up. All we have to do is cross multiply. When I do that, I end up getting 7.92 times 10 to the 24th multiplied by 1 mole, and that's going to be equal to 6.02 times 10 to the 23rd molecules times X number of moles. And this is the kind of problem that a lot of people end up dividing incorrectly. So I would always suggest doing this second step that I have in red, especially until you get really used to these problems. So I want to isolate x, so I'm going to divide both sides by 10, or 6.02 times 10 to the 23rd. Then that cancels those out. Now I have my answer of x equals 13.2 moles of calcium hydroxide. Okay, for my third problem, now this is the most complex problem we'll get to this chapter, and this is when I want to do one of the two-step conversions where I have to set up two proportions. And the reason is because if I want to convert from grams all the way to atoms or molecules, there's no direct conversion. So I first have to go from grams to moles, and then once I set up that proportion, I can then convert from moles into atoms. So we always want to go to mole first. And that first proportion is going to require the molar mass of my substance. In this case, that's aluminum. So the molar mass of aluminum, if we look on our periodic table, is 26.98 grams for every mole. So I'm going to use that, and again, it doesn't really matter which side of the proportion I put it on, so I'm just going to put it on this side, 26.98 grams for every 1 mole. And then I look at my problem, and I'm given 148.6 grams, and I want to figure out how many moles that is. So I'm going to do just what I did before. I cross multiply, and when I do that, I end up getting x is equal to 5.50778354 moles of aluminum. And I don't want to round to sig figs yet, so I want to keep that number in my calculator, and then I'm going to use that number in my next proportion. So I'm going to take the moles and I'm going to put them up here. So 5.50778, and you get the point. I'm running out of room, but there's moles, and I want to figure out how many atoms that is. So X number of atoms. And I know Avogadro says that for every 1 mole, there are 6.02 times 10 to the 23rd atoms. That's not very good too. So when I want to solve for atoms, cross multiply, and I end up getting X equals 3.316, since I want 4 sig figs, times 10 to the, let's see, where am I? Times 10 to the 24th atoms of aluminum. So there you have it. Those are the 3 types of mole conversion problems you'll see in this unit. Good luck.